Okay, so I know there's been some confusion with the Alex assignment on triangle congruence, so I want to do a few problems that should probably clear some of this up. So the first thing that you've got are a couple problems that ask about triangle congruence. And I'm going to start with this guy over here. And let me move the computer a little closer so you can see it, hopefully. All right, a little closer. Okay, so what we're looking at here, we have two separate triangles. I have triangle ABC and triangle EFG, and they may not necessarily be named in that letter order. We're going to get to that in just a second. But the two things you're trying to do is to determine what triangle in order is congruent to what other triangle, come up with that order, if they're congruent, and we'll see why that's important in a second, by what reason. And remember when I was there last Monday, we listed out all these different possibilities: side, 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 angle, side, angle, side, angle, 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 side, and then hypotenuse leg, which only works if it's a right triangle. And we also said, though, just because it's a right triangle doesn't mean we have to use hypotenuse leg. So let's go back and look. Now, not including hypotenuse leg, all the rest of these, you have to know at least three pieces of information. All three sides, two angles and a side, or two sides and an angle. So if I only have two pieces of information, I don't have enough to prove that it's congruent. Let's look here. I'm given that one side is congruent. I'm given that angle B matches up with angle G. And I'm given that angle C matches up with angle F. So first of all, before we decide how to label them, we need to decide if they're congruent. So I do have enough pieces of information. I just need to decide, does that match one of my reasons? And remember, the two that we wrote down that don't count are angle, 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 and side, side, angle. Two sides and an angle. Now, what's the difference in side, side, angle, side, angle, side? They both have sides and an angle. What's the difference between angle, side, angle, and angle, angle, side? They both have two angles and a side. Well, it's all about the positioning of the letters. Angle, side, angle. Notice the side is in between the two angles. So that would look like this. Well, the side is in between the two angles. That would be something like this, where you're talking about two angles and a side marked in the middle. Angle, angle, side. In a triangle, you're talking about two different angles and a side that's not in the middle. So two angles and a side not in the middle. So it's definitely important the order that you put the things in. Side, angle, side is where we're going to have in a triangle two sides and an angle in the middle. So side, angle, side. One of the ones we said we couldn't use, side, side, angle, side, side. That would have the angle off here to the side. And that's one of the ones that wouldn't work, so we couldn't use that. So let's look at what we have been given and see if it fits anything. So first of all, I see I'm only given information about one matching side and about two angles. So I have three pieces of information. I have enough pieces of information. Now let's look at how they fit together. The side is in between two angles. So it's angle, then I get to a side, and then I get to the third angle. Angle, side, angle. So that's this guy right here. So I can say, yes, they are congruent, and it's by angle, side, angle. Now here comes the tricky part. These triangles are oriented differently. Remember I said as long as they're congruent, we can flip them, twist them, slide them however we want. I don't want to say, oh, ABC, EFG, we're done, because they may not line up correctly. They started with angle A. So let's look up here. Angle A is the only angle in this triangle that is not marked. So the only angle in our other triangle that's not marked is angle E. It's hard for you to see that, but it does have a little E right there. So I'm going to start with E. Then they move on from A to B. B is the angle in this triangle that has one arc. We move on to an angle with one arc, and that is not F, it goes to G. So we're going to move down here to G. After G, then they move, so they do A, B, and they end up with one with two arcs, which is C. So we go E, G, and end up with one with two arcs, which is F. So our final answer for this question would be triangle ABC is congruent to triangle EGF by angle, side, angle. Now if you look at these two over here, I'm giving you two right triangles, triangle XYZ, and this other triangle over here, HIJ. Now, 2 pieces of information is enough if it's a right triangle if I am given hypotenuses are congruent, and the 2 legs are congruent, along with the right angle. I can't just assume, oh, they're right triangles, it's HL, and I move on. Let's look at what we're given. I'm given these 2 segments are congruent, and the right angle is congruent, and that's it. I don't have anything about the hypotenuse, so I couldn't use hypotenuse leg. And remember I said just because it's a right triangle doesn't mean we have to use HL. We could use one of these other reasons, but I don't have 3 things. They've only given me an angle and a side. So on this one, I would say that they could be congruent. I just don't have enough information to prove it. So you would check or pick the answer choice here that says not enough information. All right, so I'm going to write some information up here now about a proof. And we're going to look at that proof. Okay, so what I've got up here now is a proof that you're going to try to prove these 2 triangles here are congruent. Now this is going to be even more in-depth than what the ALEKS assignment would ask, because the ALEKS assignment already has some of this filled in and you're just filling in the blanks. And one of the reasons for that is these statements don't always have to go in a certain order. You could put a couple things and flip it around. So if you just fill in the blanks, you know you'll be getting it correct. So I did mention when I was there on Monday, the reason that you want to put over here to begin with always is given. And in the triangle proof, you may have more than one statement that is given. And in this one, that's the case because they gave us 2 things. Segment BC is, and if you didn't realize that equals mark with the squiggle over top, it looks like your toothbrush with your toothpaste on top. That's a congruence symbol. So that means their lengths are equal. Those segments are the same. So segment BC is congruent to DC. So the first thing I want to do is mark this on my figure. This is the kind of stuff that you should be turning in on your work when you turn in your ALEKS assignment to back it up. So segment BC is congruent to segment DC. So I've got that marked. Then segment AC is congruent to segment EC. So I'm going to mark those. And since they're separate segments, I use 2 tick marks for those. So EC and AC. Now I need to put that information into my proof. 2 separate statements, so 2 separate lines is what I'm going to do. So statement 1, segment BC is congruent to segment DC. And I know that's true because it was given to me at the beginning of the problem. Statement 2 is that AC is congruent to EC, and I know that too because it was given to me. All right, so the next thing we need to do is anything that we can notice from the problem that might help us to solve. And in this case, those things that we wrote down in the beginning of the unit in Unit A are going to come into play. They might perhaps tell you segments are parallel, and you need to notice, okay, if they're parallel, this is a transversal, I might have alternate interior or alternate exterior angles I can mark congruent. If we have a figure like this where they have a shared side, if you draw an arrow sideways through it like this, you can see what I've done right there, that shows it's a reflexive or shared side. So you can use as one of your reasons the reflexive property. If you have a side that is shared by the triangles, because it's shared, we know it's going to be the same length for either triangle if we were to separate it. We don't have that in this triangle. What we have in this one is these 2 angles across here, if you can see that, angle BCA and angle ECD. And we wrote that down in our notebook. Those are vertical angles. They're going to be the same measurement. They're vertical across. They are congruent. So I'm going to mark those with one little arc here. And I'm going to put that statement down as well. Angle BCA, or you could say ACB, it doesn't matter. Now the only thing you could not say here is angle C, because there's multiple angles that have C as the vertex point, so you have to use 3 letters. We're going to say that that one's congruent to the other side, ECD. And again, the ALEKS assignment may already give you the letters that you want to use. And the reason we're going to give here is that those are vertical angles. And we know that vertical angles are congruent. And then do we have enough information now to prove we want our final statement, to always be whatever they're wanting us to prove. Do we have enough information to say that triangle ABC is congruent to triangle EDC? Do we have 3 things? Well, I know 1, these lines are congruent, 2, these lines are congruent, and 3, these angles are congruent. So I do know 3 things. Do I have enough to say it's either right angle, angle, side, 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 one of the 5 reasons? Well, I've got side, then an angle, then another side. So I do have enough by that reason. Side, included angle, then another side. So I'm going to put my last statement, or my last reason is going to be side, angle, side. And side, angle, side is how I prove that these 2 triangles, ABC, is congruent to triangle EDC. And the reason they went in that order, A is at this corner that starts with the 2 tick marks and goes to the angle. E starts with the 2 tick marks and goes to the angle. They follow the same order that we were talking about before. I want to do one more proof that doesn't end with triangles being congruent, but that ends with segments or angles being congruent, that we use that corresponding parts of congruent triangles are congruent, CPCTC. And we'll do that one last to finish up. All right, so the last thing I want to quickly do, because I only have about 4 more minutes on this video, is this proof that ends with something other than proving the triangle is congruent. So I've got 2 figures here that are joined together, triangle ABC and triangle CDE, and they don't have to be labeled in that way. But we want to prove, we know that BD and AB are, this upside down T means perpendicular, and that DE and BD are also perpendicular. And we want to prove that A and E here are congruent angles. So that all we know so far is that these segments are perpendicular. And one thing I missed also as well that we know, BC is congruent to DC. So I've got my 3 statements that I was given already written down in my proof, and I'm going to go ahead and label those reasons as given, all 3 of them, because they gave me 3 separate things. And now I'm going to mark them on my page. All right, if 2 lines are perpendicular, then where they meet, that forms a right angle. So I can go ahead and label angle B. Where AB and BD meet, they're forming a right angle. Where ED and DC meet, they're forming a right angle. I just changed something about my figure. I made an assumption. I need to write that information down. So I'm going to add that to my proof. So what I added here next is that the measurement of angle B and the measurement of angle D are equal to 90 degrees. And my reason was that's the definition of perpendicular lines. Perpendicular lines we know meet at a right angle. So that's how I was able to make that assumption. So you can't leave any piece of information out of your statements. You've got to be very specific. So I also need to mark in here where they told me that BC is congruent to DC. Anything else we can infer from the picture, just like we did in the last problem, I can infer those angles are vertical, so I'm going to add that onto the proof. All right, so I went ahead and added that statement. Angle ACB is congruent to angle ECD because they're vertical angles, and so my statement then is vertical angles are congruent, my reason behind that. So now I have enough information, I have 3 pieces to show these 2 triangles are congruent. I have an angle, a side, and an angle. The right angle, the side they told me in the beginning that was congruent, and then an angle I got from vertical angles. So that's angle, side, angle is going to be my reason. And then I want to match up the triangle parts correctly to have the right triangles set congruent to each other. So let me do that really quickly. So I labeled the triangles congruent. I said A, B, C. I went from non-angle to right to vertical. So it's E, D, C. I matched those up that way. The last thing is, okay, now that we know the triangles are congruent, we could say any part of this triangle is congruent to this part that matches up. So AB would be congruent to DE. AC is congruent to CE. But what they want us to show, A is congruent to E. Those do match up. And my reason is C, E, C, T, C. Congruent, corresponding parts of congruent triangles are congruent. If we know the triangle is congruent, every piece that matches up is congruent. I would put this reason down here, or statement, and I would be done. Hopefully that'll help you get a better start on that Alex assignment, because that's examples of pretty much everything you're going to be seeing throughout the assignment. Hope that helps.